Hi everybody. My name is Aurélie. I work on Segula Technologies and
Good morning everyone, my name is Thomas Dalançon. I work for process engineering at Guyancourt Techno Center.
yes, and I'm the project manager. I'm the digital project manager, and today we will present you two different projects on augmented reality with Renault. So it's Check Me and Guide Me. First of all, I just will introduce a little Segula. So we are an engineering group. We work on some different sectors, like automotive with Renault, for example, or aeronautics, energy, rail, naval, pharmaceutical, or oil and gas. We are approximately 12,000 people on the world, in more than 30 different countries. And we work in innovation. We have an innovation strategy. We work, for example, in Industry 4.0, like with augmented reality or virtual reality. We work in 3D scan too, or artificial intelligence, or additive manufacturing, for example, or some different kind of technology in new materials, or connected autonomous mobility, etc., etc.
So let's jump directly to our body shop context. So I don't know if you are familiar with what is a body shop, but let's imagine that you have 200 parts, sheet metal part on the ground, and you have to fix them all together with around 4,000 to 5,000 welding spots. And each body should be manufactured in a minute, and you have to deliver one complete body to the paint shop. So let's imagine that you have to look carefully of those welding points that are disseminated on some workstation. So workstation is around 200 workstation with robots and welding guns. And so this is very important to follow all those updates, considering CAD drawing that are moving, and also those labels that are related to the welding points. So up to now, we should be compliant with the product definition in order to achieve the crash behavior of the product. And this is very tricky because at the latest point of the milestones, this is still moving. And we passed very quickly from the digital phase to a manufacturing plant, and in between we have some prototype vehicle to produce, but this is still very tricky. So how can we check the quality of our prototype and the first vehicle we build in the plant? So it's a very old system. We have some paper. Look at what we have on the screen. Maybe if you are not familiar with a body shop, maybe you could recognize a platform. This is a rear floor of a car. This is a Zoe, and maybe you can find the spare wheel location. This is very easy to understand. This is the spare wheel location, and we have all those labels that are changing. If you change the variance of the car, some points and the label is changing, the position is changing. So we have to update all those documentation, and we came to just behind the prototype or the workstation, and we take the paper and we mark everything. So this is a very slow process check. And also this is a very sensitive operation, because we have to deliver all those documentation with view, so top view, right, left, to ensure that all the key points should be in the image. So this is very time consuming. So this is really again a slow process check, and this is time and charge to update this paper documentation. So our needs is to have something that is paperless, of course, So looking with going directly in the workstation and having a tablet, this makes sense. Of course, we should have a link directly with our process lifecycle management, because we have this process planning already defined in our system. So it makes sense that we have something that bring what we already state in the product and the process lifecycle management directly in this tablet. And also we should improve decision making. So having this information directly on the tablet makes sense, because we can directly decide, okay, this prototype is fully compliant with the expectation of the product design engineering team. And additional benefit should be also report traceability, because once you have this in tablet, you have just to upload in the system that will make the trend chart for every prototype. So up to now we have some paper, mark in the paper, go to the office and put those data in the system. So we need to improve also the time, because as you may know, we have flexible lines, so this is not very easy to implement a new product. So we have only weekend and night to insert the new vehicle that is coming. If you look at maybe the plant of Douai, in this plant we build the Scenic, the long one, the short one, the Espace, and we'll build also the Talisman estate and also a sedan. So this is 5 different cars that are running in the same line. And you have only one weekend and the summer shutdown to add a new vehicle. So this is a really narrow period to introduce a new car. So that's why, in order to improve our quality check, we have in mind looking at this show like Laval Virtual. There is a lot of new technology using augmented reality, and we know for sure that now this is a very mature technology. But the idea is to have a context that is reliable with our expectation. So the idea is to take this tablet for a Check Me application or a Guide Me. This is a projector that is showing the way the guys should put some glue. So this is the first application we have in mind, is to have the glue at the right position, or to show if the tucker is at the right place, or look if this welding spot is supposed to be there, or is there some additional point that are in our specification and not in the reality on the prototype. So this is maybe you have seen directly in the demonstration in the show. You have a part that is exactly this, and you could show how we will manage this using augmented reality. So maybe I think that Aurélie will show you more in detail.
Yes, so I will present you how we decided to develop that solution. First of all, we speak with the client to decide it and to really understand what is the need. So we find 2 different use cases. The first one, Check Me, like he says, with a tablet. We decided to explain the first need is to be able to check on real time if the theoretical model is exactly the same as that we have in reality. The second one, it's Guide Me. We have to be able to guide someone on real time to realize some different operation by displaying information to follow. So for example, a position, a diameter, etc., etc. So there are different elements that he say. There is first of all a welding point, studs, and glue beds. So we decided to plan our development a little like that. There is a main task. The first of all is to validate all information that we have in 3D. So all data that we need to realize the application. The second one is to validate all different scenarios and all different visual elements. So visual elements, it's like the color and the position of welding point, for example. The third one is to develop a first application, and we have a milestone with our client to speak about that first application, and we have a client review. The fourth is to have some application update and decided with a client if the application is now over, so decided to have the final delivery. And the next one is the demonstration in the Technocentre of Renault with a lot of people to present the final solution. We plan to do all the development in approximately 6 weeks to the kickoff, so the beginning of the project, to the delivery at the end. With the need we explained to Dalançon, first of all, we decided to use the solution Diota. So it's a solution we use augmented reality without any marker. And we use that solution on tablet or on projector, for example. Why use that solution? It's because, first of all, we have a client who work on CATIA, like other different software, and it's a solution where we can take all the input data and work to the beginning to the end with that input data without any conversion. Secondly, we need we have a need for accuracy because we have to be really accurate. Yes. So that solution can be really accurate with maybe 1 or 2 millimeter difference. The third one is because we can project, and we need to project to guide me. And next point, it's because Diota is an industrial solution. We can use it on in an industrial environment. So to explain how we develop that solution, first of all, we have to define our tracking model. There is 2 different parts. The first one is we have to ask to Renault to have the 3D model about the chassis of the Zoe, and the next part is we have to take it in the reality, because we have to work and to try our application in reality with the real parts. Secondly, we have to create a visual about all elements we need to visualize, because when we work, for example, on welding points, there is only point on CATIA and we can't see them on the reality. So we have to create, for example, some sphere around a welding point to visualize him in reality. It's the same thing with glue bed. For example, we have here in yellow. In fact, it's the tolerance of the glue bed, because a glue bed can't be too big. If we put too much glue, that will be a problem after to the process. And it's the same, for example, with studs. We can choose the color and the size of the studs. So after have every 3D element and try to fix every visualization validation, we can have the result of the application. So here we can find guide me. So we will project all glue beds. Yes, all glue beds on the chassis here. Sorry, it's a bad picture. And here too. And to the other parts, you can see check me. In check me, in fact, you will check if a glue bed is okay or not okay, or maybe missing. And after, we will have a report to have every information and give it, for example, to our chief.
This is the final slides. So what I can tell you is that actually we consider as OEM that the augmented reality software are very mature. In only 5 weeks we were able to demonstrate, to make physical demonstrator on the real part. It works, and we checked the accuracy of the system. It was okay. So this was very easy. So I would say that this is a really good premise for project application first. So physical demonstration, getting in the workstation and making the check with the tablet works. So this is the first step. We win that. So of course, with that, we will have a better monitoring of a vehicle ramp-up phase and also a better traceability with reports. I would say that for CheckMe, the main issue we will have in the next future is how to feed this tablet with our existing software, getting the CAD panel part and getting all the resistance spot welding in the location with the label. So is how we will connect what we already have in our system, because everything is already defined. We know that at this workstation we have this part, this part, this part, and these welding points. This is already defined. So we have to transfer those information to the tablet. Otherwise, we will lose the interest of this technology. So this is what we should work in the next coming months. So for CheckMe, tablet is okay. For GuideMe, for sure, if you look at the system, we still have, I would say, some issue about the durability of this projector. Using it 20 hours, I think that this is not the this system will not allow to use this in the body shop. But in the prototype phase, makes sense, or during the ramp up, already makes sense. So this is another application. And I think that we have still to work on that topic. So this is what we mark is projector is not suitable for industrial environment. We have to work with the supplier and partner to work on that. But in any case, I think that really this technology makes sense and we should use it in a better way in our plant to monitor better our prototypes and also maybe our serial product. Thank you. Any comment again? I think yes. Okay.
Yes. To conclude and to see all perspective of that technology, it's we can say that augmented reality allow better traceability and production quality, reducing setup and adjustment time. But there is some different problem we can't really use that in full series, for example, but we have 3 ways of improvement. First of all, because of some bad condition in environment, we can find a solution to improve the material, for example, the projector, because we can adapt it to an industrial environment to work, for example, with a lot of dust on the environment. The second one is to adapt the workflow, because we have when we want to work on a lot of different projects, we have a lot of information to adapt and to create some different simulation, but that can be really long. So a solution can be to adapt the workflow to make that easily and faster, or maybe to automate data treatment to make that completely automatic. The next one is, for example, artificial intelligence. We can use artificial intelligence to, for example, facilitate the conformity check on an industrial solution. So I can say thank you, everybody. And if you want more information or to see that demonstration with Renault, you can meet us on the Bose E36.